That was kind of scary. Here we go. We're going to be in lesson 6.3 today. Oops. And we're going to talk about rotations. All right, so a rotation. Shh, there should be no talking right now. So rotation is a transformation. Where the figure, so that would be our preimage, is rotated, or the word that I used, turned. Oops, sorry, that's not it. So we rotate or turn a shape, but it's not just willy-nilly, that's very specifically done, and it's turned about a fixed point. So when they say fixed point, it's a point that doesn't move. Okay, so rotation is a transformation where the figure, the preimage, is rotated or turned about a fixed point. Because I'm just taking a shape and I'm rotating it around, I'm not changing its dimensions at all. I'm just changing its orientation. So it has a commonality with translation and a reflection, that the preimage and the image remain the same or congruent. So remember, congruent means same shape, same size, same length sides, same sized angles, okay? So preimage and image are congruent. So there's actually a name for that fixed point, and that fixed point is called the center of rotation. So the center of rotation is the fixed point the figure rotates around. And you can actually choose anything you want to be the center of rotation. In fact, the first example they give you, it's one of the coordinates of the preimage. So that point stays in its position and it doesn't move. The rest of the shape moves around that point. Okay, so it just shifts. Okay, but we're not going to focus on that. What we're going to focus in on our homework and what you're going to get tested on is your shape is going to rotate around the origin. So for us, this fixed point is going to be the origin. And the origin, remember, is at 0, 0. Now, the next part to the notes is going to be using a table that's in your book on page 477. And so you might want to open your book, and it might make it easier for you to copy down the remainder of the notes.
Does that say the fixed?
What's it supposed to say, Marcy?
The fixed figure?
Nope. What's it supposed to say? The fixed point. So, a rotation is not little teeny increments. Rotation, when we're dealing with our coordinate system, and we have 4 quadrants, rotates from one quadrant to another quadrant to another quadrant, okay? So each quadrant is a quarter turn. So we're going to deal with these ideas of quarter turns. Now, if you think about a quadrant, if you go from a beginning back to where you started, you've moved 360 degrees. Because if you go to the center of your coordinate system, you could draw a circle around the origin. So that's a whole 360 degrees. So each quarter turn would be a fourth of 360 degrees. So each quarter turn is going to be 90 degrees. So we're going to be rotating in increments of 90 degrees. Now we have 2 directions that we can go. So you can turn clockwise, which means you're going to rotate left. Rotate right. Hello. So you have to make sure that you're reading what direction to rotate. Most of ours are clockwise that I noticed, but you can also turn counterclockwise or rotate counterclockwise. Come on. Which means you're going to rotate left. Okay? All right, so this is where it gets gnarly. We're going to add some graph paper here for me, and we're going to talk about 3 of the rotations. If you look in your book, you've got it open, some of you do. They talk about a 90-degree rotation, an 180-degree rotation, and a 270-degree rotation. What they're not talking about is a 360 rotation because, again, 360 takes you back to where you started. So that's kind of a boring rotation because you just could draw your original figure and you're done, okay? But when you're talking quarter turns, so for you, this would be clockwise. For you guys, it's going to be this way. If I'm doing a 90-degree rotation, I'm just turning a quarter turn. If I'm doing 180, it's almost like a reflection. I've got a mirror image. And then 270, I've done a 3/4 turn. 360 takes me back to where I started. Okay. So with these, we're going to talk about clockwise. So these are all clockwise. So we're going to use CW for clockwise and CCW for counterclockwise. So the first one is a 90 degrees rotation, and we're going to do it clockwise. And what we have is our original figure. We have A, which is at, let's see, -1, 1. We have B, which is going to be at -3, 1. And then we're going to put C, I think up here. Yep. So this is A, here's B, and C's up here, and that's going to be at -1, 4. Okay. Now, we're going to rotate about the origin. So this is going to be my point of rotation, or center of rotation. Center of rotation is going to be the origin. So 90 degrees looks like this. We're going to create a 90-degree angle. And that tells me where to take my A prime to. So here's A prime. And A prime is located at 1, 1. Now this is where it's kind of hard to see because the shape doesn't just shift over, it doesn't reflect, it tips. So that tall side, that AC, when I rotate, it's going to come around down. So you're not going to have AB here, you're going to have A prime, C prime. Because that whole shape is turning, just like you're turning a spigot. So we are, 1, 2, 3. Here's our C prime, so I'm going to put him here. And C prime is located at 4, 1. And then B is 2 above the A. So there's your B prime. And B prime is located at 1, 3. Okay? So that's the hard part, is that this is the first time we are turning something. So now we have to visualize how that turn takes place. It didn't look that big of a deal when we turned the A over. We just had a little thing.
I'm just wondering, when you're rotating the 90 degree angle, can't you use the y-axis as your x-axis?
Like turn, if you look at the
If
chart.
that's what helps you visualize it, that's fine. Yeah, you could do it. I see what you're saying. So let's just take a moment and let's look at what happened to the ordered pairs. Again, I'm going to say A doesn't really show up real clearly what's happening because the numbers are both the same numbers, just different signs. But when you look at B and C, that's where we can really see what's happening to our terms. So we start with always X and Y. And look at B. The ordered pair was negative 3, 1 in our pre-image. In our image, it was 1, 3. C was at negative 1, 4 in our pre-image. In our image, it was at 4, 1. So what do you see is happening with your coordinates? Jenny?
It's going y negative x.
Your y is what's coming to the x. But the x, which was negative in C, became positive when it moved over to the y position. So we're going to take the opposite of x. But this is what's weird. This is why I'm going to recommend you guys make flashcards and you study these rules, because this is the hardest thing, is to get this straight. Marcy, focus. Okay? So our coordinates switch. X and Y go Y to X, but we also have a sign change on our X. Cameron, sit up. Next, let's talk about that 180 rotation. And again, we're talking clockwise. So we're going to start with the same beginning shape. I'm going to make this shorter. Actually, this one may need longer. And we're going to be 1, 2, 3, 4. And we're going to be A still in the same location. Come on. This is our negative 1, 1. B is going to be in the same location of negative 3, 1. C is in the same location of negative 1, 4. So we have one long side, we have one short side. Okay. When I did that rotation, I was backwards to you, right? So that's what's going to end up with ours. So a 180 is a 90 and a 90. So it's going to take us this way, because that's what a 180 looks like. It looks like a straight line. So that takes us here. I'll go to green. That is where our new A is. Okay, now think about when we were here. Our AC was now the horizontal, but we're going to continue to turn. So we'll turn down like this. So now our AC is going to be parallel to the Y. So notice what happened. AC is at an axis. Then it came down, so it went vertical, and then it went horizontal, and now it's going to go vertical again. So that's what's happening when you are tumbling. Think about a cartwheel. Hand goes down, leg goes up, other leg goes up, other hand goes down, leg comes down, leg comes down. So you're tumbling and you're changing your position the whole time. So if the A is here, what's going to happen is the B has to be to the right of the A. That's how it's going to continue on its tumble path. So the B prime is now here. And then the C comes off of the A, and it goes down 1, 2, 3 spots. So here's your C prime. So I'm going to put our ordered pairs over here. So we have the same A, which was the negative 1, 1. This B was the negative 3, 1. The C was the negative 1, 4. Our A prime ended up at negative, or 1, excuse me, 1, negative 1. Our B prime ended up at 3, negative 1. and our C prime ended up at 1, negative 4. So what's happening here in a 180? I heard somebody say something. Desi? I didn't hear you.
The X and Y are both like changing the signs.
Okay, so X and Y stayed in their same location. So we had a 1, we have a 1, but the thing that changed was the signs. So what we do is have a negative X and a negative Y. And again, remember, negative doesn't mean you always put a negative sign. It's just the opposite to what it was. Okay? And that makes sense. So now we're going to tumble one more time for a 270. And notice where the AC is. It's been vertical in the 90, or in the original. Then when it went 90, it went horizontal. When it went to 180, it went to vertical. And now the AC, when I go to 270, is going to go back to being horizontal. So we have a 270 degree rotation clockwise. And we start again with our A, which was at the negative 1, 1. The B was at negative 3, 1. And our C was at negative 1, 4. And so we're going to continue the pattern. And here's what it looks like. We're going to go through the 90. We're going to go through the 180. And then we need to go 1/4 turn more. So it goes past this, and it goes over here. So it has to make this entire rotation, 3/4 turn. So this is your new A prime. The C prime is what is now going to be flat. So 1, 2, 3. So here's your C prime, and B is going to be below the A. So here's your B prime. Okay, so if I do my 3 order pairs again, where A is at negative 1, 1, A prime ended up at negative 1, negative 1. Again, the A in this case is really hard to see a pattern. B is where it starts showing up. So we were at negative 3, 1, and then B prime, we now ended up at negative 1, negative 3. And then C started at negative 1, 4. And our C prime ended up at negative 4, negative 1. Okay, so what's happening here? Well, we start with our XY, so that's the, let's say on C, the negative 1, 4. What happens to our variables? What happens to our coordinates? Talia?
They switch, but the signs are the same.
Okay, they switch. Now, I agree the X's sign stays, but I see a sign change here.
Like the signs are the same for like both coordinates.
No. Because if that was the case, this would be negative 1, negative 4, and then that would make it negative 4, negative 1. But notice, this was a positive 4, and now it becomes a negative 4. So this value, the Y value, is changing signs, but I do agree with they are switching places. So the Y this time is the one that ends up getting the sign change, but the two coordinates swap places. So the X value becomes now in the Y place, the Y value is now in the X place. But again, the Y does change signs. So this is so hard, okay, because the easiest thing to do is to keep this rule in your mind when you're doing this, because it is hard sometimes to visualize the adjustment, okay? So what I want to do is do one problem. Oh, and by the way, a lot of people don't do 270 degrees rotation clockwise because that's hard to kind of go around and have an angle that's bigger than 180. So what some people do is that what's the same thing as going clockwise 270 degrees is to go counterclockwise one turn or 90 degrees. So a 270 degrees rotation clockwise is the same thing as 90 degrees rotation counterclockwise. And they have exactly the same rule.
So is the rule for counterclockwise and clockwise opposite? So like, would it be 90 is 270 for counterclockwise?
Right. But again, most people don't want to do the 270. So really what you're paying attention to is 90 clockwise, 180 clockwise or counterclockwise is identical, right? Because 180 is 180. You're not going to get anything different. But it's when you get to a 270, it's easier to go just one turn instead of three. Okay?
So for the rule, it doesn't matter if it's clockwise or counterclockwise, but it does when you don't.
Right. When you're pairing up 90 clockwise with 270 counterclockwise, 270 clockwise with 90 counterclockwise, the rule is the same. Okay? All right, so let's do one example. And this one is going to give us a triangle, DEF, wherever you have room, because this just takes room. Yep. With vertices, D is going to be at negative 4, 4. E is going to be at negative 1, 2. And F is going to be at negative 3, 1. So again, doing homework in your book is going to be helpful because they have the graph paper there for you. Or if you want to do it on your own, that's fine. You're going to graph the figure, which is the preimage. And its image. Oh, image. After a clockwise rotation of 90 degrees about the origin. So you need to read to find several key pieces of information. Number one, what is that fixed point you're rotating around? So that's the origin. What direction are you going, clockwise or counterclockwise? And how many turns are you taking? 90 would be one turn. So clockwise is to the right. So we're going to move to the right, one full turn about the origin. Okay? So then we're going to give the coordinates of the triangle D prime, E prime, F prime. What's going on? So I'm just doing a 5 by 5. X, Y, 2, 4, 2, 4, negative 2, negative 4, negative 2, negative 4. So I'm going to graph my triangle DEF. So D's at negative 4, 4. E is at negative 1, 2. F is at negative 3, 1. And then we're going to rotate it to the right about the origin. So this is where it gets tricky. Okay? So what's going to happen is that DE is going to come over and be closer to the x-axis than the FE. Okay? When I do that quarter turn, that's what's going to happen. So what I'm going to try to do is visualize what a 90-degree angle would look like. And I remember with 90 degrees clockwise, I'm going to just write my rule down here to remind myself, is that we swapped places with the x and the y, and we took the opposite of the x. So that's going to help me with this. So I can do this with point E to help me start off the process. So E is at -1, 2. So according to the rule, E prime is going to be at 2, and the opposite of -1 is 1. So here is where E prime ends up, at 2, 1. And again, here's your 90 degrees. Okay, so you could actually physically use a protractor to measure where 90 degrees would be from the origin along the line of where that line DE is, and see if you could draw it in. Once I get that in, then I'm going to figure out the rest of them. So I'm going to use my rule to help me with this. So F was at -3, 1. So F prime is going to be at, switch the order, change the sign on the X. So F prime is going to be at 1, 3. And remember what we said is that the FE isn't going to be along the x-axis. Okay, Connor and Marcy, do I need to split the two of you up? Okay, no, you need to focus today. And then D started at -4, 4. So D prime, we're going to switch the order. So the Y goes in the X spot, the X goes in the Y spot, and then we're going to change the sign on the X. So we're going to go to 0.44. So here's my triangle. So we got E at 2, 1. We have the F is at 1, 3, F prime. We've got the D prime is at 4, 4. So that DE is on its way tumbling towards the x-axis, which is exactly what it should do. So that's what you guys are going to be doing tonight in your homework on the pages 478, 479, 480, 481. Sometimes it's going to be a triangle and sometimes it's going to be a quadrilateral. But again, with this, for me, I need to go use the rule and then graph it because I have a hard time. This is not one of my natural gifts to understand how things end up. So this is the way that I get it right. Okay?